Alright, 10.5 talks about inverse of matrices and also talks about matrix equations. So let's get the inverse of matrices. To talk about that, we need to talk about the identity. The identity matrix, well, the identity real number is 1 because if you take any number multiplied by 1, or 1 times any number, you get the number itself. So that's what identity means. Multiply by quantity and get the same value back. So multiplying by this identity doesn't change the value of whatever it is you're multiplying with. In matrices, I sub n is a square matrix. What does square matrix mean? Square matrix means the number of rows equal the number of columns. And when you draw it, it doesn't look like a rectangle, it looks like a square. That's where the name comes from. So a square matrix in which all the diagonal entries are those, are 1. And all other entries are zeros. And that's how it works. So the identity for a 2 by 2 is 1 across the diagonals and 0 everywhere else. 3 by 3, 1 across the diagonals and 0 everywhere else. For I sub n, 1 across the diagonals and zeros everywhere else. Now, matrices, matrix-wise, if I take matrix A, for example, and I multiply it by the identity associated with it, or take the identity matrix times A, I should get A back. The values of A should not change. That's what we label sort of like a 1 when you multiply real numbers with the identity. So 1 is the identity in real numbers, and I sub n represents the identity for the nth matrix. So in example 1, we're verifying that. Let's look at that and make sure we are convinced. So find AI2. Well, AI2 would be a 1324 1001. That would be, to generate the first row, I use the first row, so times 1 times 1 is 1 plus 0. And to generate the second, I multiply by the second. 1 times 0 is 0, plus 2 times 1 is 2. To generate the second row, I would use the second row times the first. 3 times 1 is 3 plus 4 times 0. And 3 times 0 is 0 plus 4. And what do you notice happens? I get A back. And if I decided to go the other way around, if I wanted to do I times A, and do remember, AB in matrices or matrix land is not the same as BA, but here you'll notice I'll get a 2 by 1. Again, to generate the first row, I use the first row. So 1 times 1 plus 3 times 0, 1 times 2 plus 4 times 0. To generate the second row, I use the second row. 0 times 1 plus 1 times 3, and 0 times 2 plus 1 times 4. And I end up with a 1, 2, 4, 4. Actually, that should have been a 0 plus 3, so that's a 3. And you notice I get the same thing back. And if I tried that on 3 by 3, well, the work is a bit more tense, but it's the same idea. 1, 0, 0, 0, 1, 0, 0, 0, 1, multiplied by 2, 5, 1, 0, negative 3, 6, negative 1, 2, 1. That would be a 3 by 3. And to generate the first row, I use the first row. And the first entry is a 1. So when I multiply it by this, that's a 2 plus 2 zeros. When I multiply the second, only the first entry survived. That's 5. The rest are all zeros because those are zeros. and 1 for this. Here, to generate the second row is the second row. Notice only the second entry is a 1. So 0 times 2 is 0, 1 times 0 is 0. So only the second entry of each row is going to survive, because the rest is going to be 0. And to generate the third row, I use the third row. Notice only the last entry is a 1. So when I multiply it by the first row, only the third entry will remain. In the second column, right, only the last, and in the third column, only a 1. And if I do, was IA. If I want IH, I'm sorry. And if I do HI, well, write H first. Multiplied by 1, 0, 0, 0, 1, 0, 0, 0, 1. And the first, I use the first. 2 times 1 plus 5 times 0 is 0, 1 times. So again, only the first piece will survive. For the second, 2 times 0 is 0 plus 5 times 1 is 5. Only the second piece will survive. And for the third one, I multiply by this. 2 times 0 is 0, 5 times 0 is 0, negative 1 times 1 is negative 1. That's not a negative 1, that's a positive 1. And to generate the second row, I use the second row. Well, times the first. 0 times 1 is 0, negative 3, so that's a 0. For the second, 0 times 0 is 0, negative 3 times 1 is negative 3, plus 0, that's a negative 3. And as for the third, 0 times 0, negative 3 times 0, 6 times 1 is 6. And to generate the last, I use the last. Negative 1 times 1 is negative 1, 2 zeros. When I multiply by the second, only the middle will survive, and when multiplied by the last, only the last will survive. And you notice I get it back. And that's what identity stands for. Now that was identity. Now we gotta talk about something different, slightly different, a bit more complex. Inverse. For real numbers, the inverse of A, assuming A is not 0, is what do I multiply A with to get the 1? If A is not 0, then 1 over A. For example, if I have 7, you multiply by 1 over 7, you get the 1. So the inverse is what do I multiply my matrix with, or my number with, to get the 1? 1 is simple. You multiply by 1, nothing changes. But an inverse is what I multiply my number with to get the 1. So, given a square matrix, if the inverse of A, we denote it by A with a negative 1, just like we did the inverse of F is F to the negative 1. If the inverse exists, then if I take A multiplied by its inverse, or the inverse times A, I should get the identity matrix. Here it says, 2 examples. Find, I should have made it A and B. I didn't. My mistake. Okay, now I see. My mistake again. Here. No problem. I can fix that. Alright. So example A and example B. Let's get those separated. So what I want to find AB. Well, AB is really 1, 2, 2, 5 multiplied by negative 1, 2, 2, negative 1. And I'm going to work to the side so we see it. To generate the first, we use the first. That's going to be 1 times negative 1 plus 4. Oh, I messed up. Okay, there it is. I fixed it. I'm sorry. Here we go. So again, this is really 5, negative 2, negative 2, 1. So if I multiply by the first, 5 minus 4, and if I multiply by the second to generate the first, that would be 1 times negative 2 plus 2 times 1. To generate the second row, I use the second row. For the first, 2 times 5 is 10 minus 10 for the second. And for this row, 2 times negative 2 is negative 4 plus 5 times 1 is a 5. Again, I should be working downwards, not to the side, but I just wanted to line them up so you could see them. It's easier this way. And that would be 1. That's a 0, 0, 1. That worked. That's not enough. I still have to do BA and make sure that I get the identity matrix. If that's the case, because sometimes it works in one direction and it doesn't work in another direction. So to generate the first row, I use the first row, and that is 5 times 1 is 5 minus 4, and 5 times 2 is 10 minus 10. And to generate the second row, I use the second row. Negative 2 times 1 is negative 2 plus 2. And negative 2 times 2 is a negative 4 plus 5. And that turns out to be a 1, 0, 0, 1. So what can you conclude? I conclude that A and B are inverses of each other. It doesn't matter which is which. A and B are inverses of each other. So one of those is the inverse of the other. If I go for AB on part B, well, the same deal. AB, let's write A. 1, 0, 2, negative 1, 2, 3, 1, negative 1, 0. Multiply that by 3, negative 2, negative 4, 3, negative 2, negative 3, negative 1, 1, 2. Again, I'm going to work to the side. To generate the first row, I use the first row. So 1 times 3 plus 0 plus minus 2. For the second, I use the second, negative 2 plus 0 plus 2. And for the third, negative 1 times 4 is negative 4 plus 0 plus 4. To generate the second entry, I use the second row. That will generate the second row. To find the first entry, I multiply negative 3 times 1, that's negative 3, plus 2 times 3, that's a 6, plus 3 times negative, that's a negative 3. And to generate the second, negative 1 times 2 is 2, 2 times negative 2 is a minus 4, and 3 times 1 is a 3. And for the last, I'll get a 4 minus 6 plus 6. 4 minus 6 plus 6. Okay, so that was a negative 5, my mistake. That doesn't alter the previous, but for this piece, that will alter this. That will make it, so that should be a negative 5. That will be, for the third entry, 4 minus 10 plus 6. And as for the last, I use the third to get the third times the first, that is 3 minus 3 plus 0. And for the second, negative 2 plus 2 plus 0. And for the last, 4 plus 5 plus 0. And that turns out to be a 1, 0, 0, 0, 1, 0, and this is 0, this is 0, this is 1. There it is. And if you do AB, you would notice that that's also the identity, and you make the same conclusion that A and B are inverses of each other.